Hi there. Today we're looking at section 5.4 on the midsegment. Now the midsegment itself is a very easy concept. If I draw a triangle and I find the midpoints of two sides and I connect them with a line segment, that line segment is called the midsegment, and it is in fact parallel to the opposite side and half its length. So if the length of this one's x, the length of this one is 1/2 of x. Notice, by the way, that I could draw three midsegments, just like that. And this one, of course, would be parallel to this side and half its length, and this one over here would be parallel to this side and half its length. Now, we're going to use that information over here to solve a problem. If you will notice, I have drawn a blue triangle inside here with vertices D, E, F at 2, 4, 3, 2, and 4, 5. These are the midpoints. These 3 points are the midpoints of a bigger triangle. I've sketched in the bigger triangle here, but what I'd like to find is the coordinates of point A, point B, and point C, so that D, E, and F would be the midpoints and these would be the midsegments. To do that, I'm going to find the equations for each of these 3 lines, the black lines out here, and when I put them together, solving simultaneously, I will find the coordinates of point A, point B, and point C. So I'll show you how that works. In order to find the equation for line AB, I first have to look at the slope of the line it's parallel to, the midsegment. So the slope is 4 minus 2 is 2 over 2 minus 3 is -1. That's a slope of -2 plus B. Now I have to find B, and the way I do that is to plug in 4, 5 and use that to find the equation for line AB. So 5 equals -2 times 4 plus B. This becomes -8 plus B. So I add 8 to both sides, I get 13 equals B. So AB then is equal to y equals, let's do it this way, y equals -2x plus 13. All right, there's the first one. The second one, let's look at BC. In order to do that, I have to find the slope of this line here, the blue line, which is parallel to it. 5 minus 4 is 1, 4 minus 2 is 2, that's a slope of 1/2. So y equals 1/2 x plus b. In order to find b, I put in 3, 2, because that's a point on this line BC, which is the one we're finding. All right, so the point 2 equals 1/2 times 3 plus b. This is 3/2 plus b equals 2. I subtract 3/2, and 4/2, which is 2, minus 3/2 is 1/2. So b is 1/2, so I have y equals 1/2 x plus 1/2. All right, there's the second one. Now the third one that we don't have yet is AC. AC is over here, so we have to look to this slope right here, which is 5 minus 2 is 3 over 4 minus 3 is 1. That's a slope of 3. So y equals 3x plus b, and in order to find that, I have to look at this point here, 2, 4, which is a point on line AC. So 4 equals 3 times 2 plus b, that's 6 plus b equals 4 minus 6, and I get b equals -2. So y equals -2x plus minus 2. I'm sorry, back up, y equals 3x minus 2. All right, now all we have left to do is put them together. To do that, I will take any two. If I use A, B, and BC, I will find the coordinates of point B. So let's do that. And I'm going to use the substitution method because y equals negative 2x plus 13 and y equals 1/2 x plus 1/2, I can just set these two quantities equal to each other because they're both equal to 1/2. So negative 2x plus 13 equals 1/2 x plus 1/2. First thing I'm going to do is get rid of the denominators. So I get negative 2x plus 26 equals x plus 1. Now, if I subtract 1 from both sides, I get 25. I have negative 2x. You know what I did? I have to go back and multiply that by 2 because I didn't do that. So let's back up to this point. That should have been, this was a negative 2, but this then should have been 4 because remember, I have to distribute to all the terms, and don't make the mistake I just made, please. So now I'm going to add 4x to both sides, and I get 5x over here equals, I subtract 1, I get 25, so x equals 5. All right, does point B look like it's out 5? Yes, it certainly does. All right, so we take that 5 and let's put it back in to one of the two original equations I was using, and that would be, let's put the 5 in here. That's negative 10 plus 13 is 3. So it looks like point B is at 5. Let's see, you probably can't see that because it's off the graph. So I'm going to put it over here. So point B appears to be at 5, 3. Now, let's see if that looks reasonable. Of course, my drawing wasn't exact, but there's the 0.53 right there, and that's very close to it. All right, the next one we'll do is to use, let's see, we used these two. Let's use these two, A, B, and AC, to find point A. So negative, here, I have to stay in your screen. Negative 2x plus 13 is equal to 3x minus 2. All right, and that would be, let's say, 5x. If I add the negative 2x equals 15, so x equals 3. Now, does that look reasonable? Yes, 3, and it's right up here. And I take that 3 and I put it back in here to either one of these two. 3 times 3 is 9, minus 2 is 7. And that's pretty close to where we are. So 3, 7 is point A. We'll put that over here. 3, 7. And now we have just left to find point C. And in order to do that, we will use BC and AC. So y equals 1/2 x plus, let's try that again. 1/2 x plus 1/2 is equal to 3x minus 2. And now I'm going to multiply by 2, so I get x plus 1 equals 6x minus 4. I subtract 1 and I get negative 5 equals, I subtract the 6x, I get negative 5x equals negative 5, or x equals 1. If I put that back in to either one, I get 3 times 1 is 3, minus 2 is 1. So I have a point 1, 1. And point C then is at 1, 1. Let's make sure that's more or less readable. 1, 1. All right, let's see. Does that look reasonable? 1, 1 would be right here. Obviously, I was a little bit off. We had 5, 3, which was over here. Again, mine's a little off. And we have 3, 7, 3, and that would be right here. So again, I'm just a little bit off. So that's how you do it. It is a bit tedious, but there's nothing here that you haven't done many times before. You know how to find slope. You know how to find y-intercept. You know how to put two equations together using either combination or substitution methods. So it's all algebra, but what we are using is the concept of the midsegment, in which, just to recap, a midsegment is drawn between two midpoints in a triangle, and it is parallel to the third side and equal to 1/2 its length. If I draw them all, I get something like this. And what I was doing over here, this was A, this was C, and this was B. We were taking what was given inside here, this little triangle and finding the original vertices of the bigger triangle. All right, thank you very much. I'll see you next time.